And there are other packages that I took the liberty from the Olive will also be teaching, different statistical methods. So you will be using these packages. So is everyone clear about how to install a package? Yes? So you can install these packages either one by one or by just making, a list of these packages like I've done here, package list, or you can name it anything, then make a list of these packages, let's say ggplot2, then xlsx, and then, okay, right? Okay. Yes, so make a list of the packages and then you can install them all together using the same command. Okay, so when you're working with R, you need to install these packages only once. As you can see, installing these packages takes time. So you just install them once in your computer, and next time you close R, when you open your R, you don't need to install them again. You just need to load the package using this command called library. That is why when you install the package, you can just, comment it. Once the package installation is done, no need to do it again. So we will load the packages, and this is the command to load the packages. Library ggplot2, then library xlsx, like that. And some of you got the error that how many of you got the error while installing, right? Java, R Java. So what happens is that with R, it happens a lot because there are, updates, version updates. Many packages are updated, but this particular error occurs when there is a mismatch between Java version and R version. So to tackle that, what you need to do is you manually install Java in your system using this link, right? So this is on your page 5. If you're getting this error, you can manually go to this website. And if you manually install Java, depending on your system, it's 32-bit or 64-bit, you can install it, then you will not get that R Java error. So were you able to follow until the point of installing the packages and loading the packages? Did you receive any error? Okay. Yes, if you install the Java manually, this error will go. Okay, so for this particular exercise, I don't think you need all the packages. So I think ggplot2 and xls and I think dplyr would be enough. Now let us continue with the variables that are available in R. So so now let us move on. Yes, so how do we define a variable in R? So we can write either a sign like x equal 2, or we can even use this symbol x, right? They are both the same. However, I would suggest it's easier and safer to use the second option, because when you are putting this in a function or it's nested, then this assignment works under most condition, while the equal sign may not work. So that's just one suggestion, but both way you can assign a variable. Okay, and now let us see what are the types of variables that are available in R. So just like any programming languages, there are some simple variables. There are like numeric type. So to show that, I will show you this table, right? Okay, so you have numeric type like any real number, It can have decimal points. Then you have character. Character can be an individual character or it can be a string. And you can, when you assign, when you write it, you can either use single quote or double quote. Both are acceptable. And then we have a variable type called integer. It is a whole number. And then, so let us see integer and numeric, for example. We have just defined x equals 1. What class should it have? Any guesses? Class of x. Numeric, right? So let's see 2.5. Class of x is still numeric. And sometimes what we do is that we can convert these variables. For example, y equals as integer x. Then y is an integer and we are converting x, that is 2.5, into an integer. So let us see what y we should get. It's 2. So integers are basically whole numbers. So that was the point. And to see the class, again we will see class. We can write the variable name and then we'll get the class type. Similarly, we have discussed character. So it can be either single quote or double quote, both are fine. So again, this is your character. So far, so good. Then we also have factor. So this factor is useful because sometimes we have data, we have multiple values. For example, I have a list of students, then I have either this factor is a categorical variable to, we use it as a factor. For example, I'll come back to my example. We have a list of students. We have, for example, male or female. We have classification UG or PG. So these are, your factors to divide your data. And I think it will make more sense when we work with the examples, right? Okay, so that is your factor. And then we have a variable called logical. So logical, either it will be true or false. True or false. So let's see. Let's x equals true, false. Yes. Yeah. So when we are giving multiple values, we use this C term. Okay. So now let us see the class of x. This is your logical, right? And sometimes if we have, let's say, 0, 1, 0, 1, and then we can what is the class of this? Currently it is numeric, but if we 0, 1, if we want to convert it to logical, let's say y is as logical x. Then let us see what is the class of y, logical. Let us see what y looks like. What are you expecting? So we just converted this x that was 0, 1, 0, 1 to y, to logical. What should we expect? False, true, right? So 0 will be your false and 1 or even every other value will be considered true. So this is your logical type of variable. Is this clear? Then we have other variables that deal with date and also with time. And we will see, for example, when we are, let me tell you, working with dates and time is a little bit challenging compared to other formats, like numerical characters are easier to work with. And R will use a standard format. So if, for example, if I convert something as date, just like we have converted, it's good to give it in a standard format. That is your ISO format. So the ISO format will be something like this, YYY MMDD, just like this one. So if we use this format, R will know what date it is. For example, X is equal to as date. This was the format 01, 01. So class of X is date, and let us see, X is, so this is the standard format. But if you're not using the standard format, then you have to define like we just assigned X a particular date. For example, if we want to deviate from the standard format, then we have to tell R exactly how to read that. Okay. So again, X as date, and this time we are giving, let's say 90, 70, 10, 10, and in this way we also have to give the format. So let me see. Format, and we have capital Y, then there is a slash after the Y, then we have month, then we have slash, then we have day, right? So now R will know that it is a date and it will correctly identify that date. And there are like two ways to define a date. If we give 4 digit, we will use capital Y. If we use small digit, it is representing year format in 2. Okay. So is the date format clear to you? Right. And that there is you can also find out what is the date today by using just this function sys.date. So it will give you the date for today. Similarly, you can work with time, and it will give you the time. So I think now we will move on, because again I will repeat that working with dates is a bit tricky in R. So I think if you have your data, then it's better. And for working with dates, there is this package called lubridate that is very helpful. Okay. So I think we have covered different variables, and this is what I was telling you about factor. For example, we have X. Currently, it is a character class. It has UG, PG. Now we want to give the factors, so we can just use as factor Y, and then if you try to print Y, right? So, yep. So it will just categorize the data. So it will find the unique values, and those will be your factors or categories within that particular variable. Okay. So I think we have covered different types of variables. Any questions so far? What are the different types of variables that we can work with in R? Okay. If not, we will go to the list. So to define a list, we can just use this function list, and inside it we can just give any numbers, anything, and we can even have mix and match the classes. A list doesn't need to have same variables. So it is a list, and to be able to access a particular element of the list, we will use these double square brackets, right? And you see let us see what is the class of the first element. It's numeric. And let us see what is the class of the fourth element. It is character. So this is one way to work with lists in R. We can create our own list, named list, right? For example, in this example that we just looked at, we randomly gave some numbers, but we can also give names to those. Let's say X is equal to list, then serial number, let's say C, 1, 2, 3. Then we can have names, let's say John, Alex, Max, right? So this list is again a list, but it is a named list. So each element we have given it a name. Okay. So now let us go to the data frame. Data frame. Because data frames are very useful. They are just like Excel. In Excel, we have rows and columns. They are easy to work with. Similarly, here we have a data frame. Let's see. So in this example, we will again we can take the example like earlier we had. We have these three variables. One is your serial number, one is your names, and then you have marks. So you can convert this into a data frame by using this function, data frame, and then your first column will be your serial number, second column names, then marks. So this is your data frame. To view the data frame, you can just use the view command or like this, or you can directly go to your environment or click on the particular variable. So this is your data frame containing rows and columns. Okay. Are there any doubts so far? Installing packages, loading packages, and working with different types of variables. So what are the variables that we've looked at? Numeric, character, integers, and then we also had logical, we had date, time, and then we had also more complex like lists and data frames. Now let us read an Excel file. I think this is something that will be very useful for your research also, because a lot of the times your data is in CSV or Excel. So here let us read the Excel file. Okay. Yes. So before we do that, I think it's always a good idea to have a look at your data outside first, right? Let us have a look at our intro data. Intro data. So this is your data. It has two columns. One column is year, other column is yield, tons per hectare. Then you also have this, this character in the second row as well. And then you have yields going from 2003 to 2021. So this is your data, and this is what we are going to import. Okay. So we will, again, we can use X. Are you able to see this part, or should I increase the font? And also this, you can find this in your in the PDF file as well. So now we are here reading the data. So let us read this data, and before doing that, you need to have this XLSX library. So first install this library, then let us read a data using this function read.xlsx. Here you can give the path, right? So to get the path, what I do is I just go to the where the file is saved. Okay, this is my file. Let's see the properties. Then you can copy the location of the file. You insert it here. Then you write the name of the file, that was data intro.xlsx. And all this needs to go in a double quotes, because it's a string. And remember that when we are copying a path in R, we need to use these slashes. We need to change them. We need to make them forward slashes rather than backward slash. Okay, so I think I was too quick to run the code. So first step is give the path, and the next step is give the name of the sheet. So the name of the sheet is sheet 1. So were you all able to import the sheet? Yes, I think it would be good if you are able to import this sheet, because we will be creating some graphs using the sheet. Okay. So I would encourage you to install this Excel sheet, and you don't need to install all the packages right now, just the ggplot and then XLSX. That would be what we need. Okay. Hmm? So once you are able to read that Excel file, let me know. You're able to read that file? Hmm?
I have version है मेरे पास old version 4.2.1 बट अभी ये जो एक्सेल जो लाइब्रेरी है वो इस कोड नहीं कर रही इस वर्जन को
So library नहीं करी है. So there.
को मतलब अपडेट करना पड़ेगा.
Yes, or there is another function, read Excel. Okay. So how many of you were able to read the Excel file? Okay. If not, that is okay. We have some plot example using, some example data in R, because R contains some example data like the famous empty cars or pressure data. So we will be using the example data. But I would like your attention here, because I want to show you one point. We just, let us see. So we just read this Excel file. So let's see what it looks like. So just like we saw in that Excel, you got your first row as your column names, and then again it reads as it is. However, let's see, year, what is the class of the year? So here the class is, no, not this. So now we want to access column of that data frame. So X is our data frame. So we will use this $sign to get to the year. So the year column, it is a character, but we want it to be a numeric, because if we want to make plots, we want to calculate mean, so we want to work with numerical data. So many a times it happens that you have your column, you have your numerical value, but in between you have none or something else, some character. So if you have that, then it creates problem. So in this example, we can fix this simply by making our read from the second row and forget about the first one. So let us see how we can do that. So again, we will do this R X read XLSX. Then we will give the path. Then sheet name equal to sheet 1, and then there is a function to skip the rows. Here the function is start row. So we will start with row 2. So now let us see our data, what it looks like. So now we have year, our the problem is gone. So let us see what is the class of our year. So name of the data frame, $sign, and the name of the column. So now it is a numeric. Same for the second column. That is your sorghum yield, right? So that is your numerical. So I hope with this example, you are able to see how we can read Excel file. We need to give a path, we need to give sheet name, and we can also skip rows. And some of you might be having an issue, like someone mentioned that they were not able to have this function read.xls. So it is not the only function. There are different packages, and in different packages, the naming will be different. For example, in another function, there is read XLS Excel function also. Instead of start row, it will say skip, right? So again, there are different ways to do it, but I think some of the arguments will remain the same. So what do I mean by argument? So this read XLS is a function. So everything that we give inside is your argument. And if you want to know more about any function, what will you do? You can go to the help, you can go to the documentation, and you can do that by typing this question mark and the name of that particular function. If you do that, then you will see that in the help section here, a documentation will come up. So it will tell you, we only gave it file path, we gave sheet name, we also gave start row, but there are options of multiple arguments. Some of these are essential, some are not, but for any function, if you want to know more information, there is documentation online, and from here also you can access using the question mark. So I hope with this we are clear about how to read a file in R, right? So now we will export some data from R. So for this, I will use data called pressure. So as I mentioned, there are some example data in R. And I think it's helpful because sometimes people have issue in importing the data. So I think for demonstration, we can use these default data sets. So let us see what this data set is. Let us call it PR. That is your pressure. So this pressure is your default data. So let us have a look at this function, and we can do that using either view, or we can simply go to the environment and see it. So it has two columns called temperature and pressure, and it has how many values? 19 values. So we can create some plots using this example data as well. So any questions so far? Reading and writing? So just like we read Excel file, to export some data into an Excel, we will just use this function write.xlsx, then name of that variable that we want to export, and then we will give it the name. Let's say pressure.xlsx. So, okay. So I have written it. Now I want to see it where it is in my computer. So where should I go? I have written this, I just use this command to export or write an Excel file, and it should have been created, but I don't know where it is. So how will I know where my file is? Right? So what happens is that in R, see, for importing, I gave the full path, right? So if you are giving the full path like C, then folder name, then it will go to that folder. But if you are not giving the full path, then it will go to your working directory, right? So let us see where the working directory is. And to do that, you can use the function getWD. GetWD. So this is my path. I will go to that path, and here my data should have been exported. Right, so it is exported here. And usually what happens is that your working directory is where your code is. So my code.r file is here in this folder, in this directory. So usually if I generate some graphs or export anything, by default, this is your working directory. And if you want, you can change your working directory as well using a function called setwd. Is this part clear? What we did with the get working directory? Similarly, we can, set working directory if we want to change it. But for now, we are not going to make that change. Now, let us move on to ggplot, and we will create some graphs. Okay. And again, for this purpose, I will be using the example data. So I think everyone should have, no problem in preparing this plot. So if you have not done already, you need to load the package that is ggplot2. And then here, let me use this pressure as the data. So for working with ggplot, first you write ggplot, and the first thing you do is that you tell what data I want to plot. So here we want to plot this PR. And when you're working with ggplot, at the end of every line, you will use a plus because you are making a plot. You want to know it is a point plot, line plot. So everything is connected. So to make that connection, you will be using that plus sign. So we have told it, okay, this is our data. And for making a plot, what do we need? We need x-axis, y-axis, right? What we want to plot. So I have told ggplot, this is my data. Now I have to tell it what are my axes. So I can use this AES function for that. And then I can define my x-axis. Here, let us say temperature, and y, let us say pressure. Okay. Then I will add a plus because I have just told it, this is my data, these are my axes, but what type of plot I want. So there are different plots options. So here let us start with a simple one, that is your point. So to do that, I will use geom point. Okay. So by doing that, I got this plot here in the plot section. So I think this is something you all can do in your computer because you don't need to import any data for this. Okay. Okay. Yes. So are you able to make a point, geom point? Right. So similarly, you can make a line plot using geom line. So again, we will start. What do? We have no. See, I'm writing it directly in the console, but I think you should write in a script, but I already have it, so I'm not writing it here because you don't want your code to go away. So write it here. If you want to run the code, either use this function or select the lines you want to plot and use Control Enter. Okay. So now we will create again. Let's start from scratch. So now we are familiar with the pressure data. So again, ggplot. What is the first thing we need to do? What is the first thing? We need to tell it what data we are using. Then what is the next thing? You can either use AES, AES or AES string. So in string, the difference is that you can, specify your variable name as a string. And I have found it very useful, especially if you are running something in the loop. If you want to change your variable name, then I think it is good to have, a string. So that is something that I find useful. So you define your axis. The next thing you can do is now let us make a line plot. So then it gives us a line. Okay. And we can create both in the same graph, line as well as point. Yes. String. Yes, yes. So this is a trick that I found, that if I want to automate my plots, because if we use AES, we have to give the name in this format. For example, let us create another column. Here, serial number. Serial number is equal to row names ER. So we just created another column. In this, we gave these numbers equal to the serial to the row names, and let us see what is the class of this SN. That is your data frame name and the name of the column. So this is a character. Let us see if we can convert this into numeric. Okay, so what I just did is I placed row name as a new column, and I converted it to numeric because I want to demonstrate you how to use this in a loop. Okay, so now I want to make a plot, and these are my variable names. Variable names are pressure, temperature, and I want to plot them in loops. So I can say for I in one length of that variable names, right? So are you with me here? So instead of, so X, let us give this serial number, and in Y, instead of giving the name, I will use a loop. So where names I. Make sense? So are you able to see the error? I'm getting some error here. Okay, error is this. Okay. So this way I'm able to create two plots. So that's what I meant, that instead of using AES, if I use string, then I can, make it's easier to work in a loop if you want to create plots in a loop. So that's the point. Any questions? Hmm? Yes, yes.
To make the sizes of the points present the soil body density.
Yes.
Is also.
What I would say is that let us keep to the basics for now, because I'm guessing that some of you are not very familiar with R. So I think so far we have learned ggplot and then geopoint and line. So let us also cover some other basic plots that are your box plots. Okay. So in this, for this example, I will again go back to the data that I imported from that file, this year file, and if I want to see the columns of that, I will use this. I can use this function names, name of the data frame, and it will tell me what are the names of the columns. So in this example, I am plotting, giving data X, and here in geopoint, you can even give it a color, and you can use this function labs to change the labels. So let's see if we run this, what do we get? So we get a colorful graph, and our label has changed using this labs function. Okay. So I think so far we have covered point, line, and how to add colors to it and change the label names. Now many a times what we do is that we fit a line to a data, right? We want to fit a line. So let us again go back to our data. Our data is this data frame again. And what are our x's? Here, let us put year in x, and y we can stick with the sorghum yield. Then let us create a geom point. So if we do that, we will get a simple point. And if we want to fit a line to it, there is a function called geom smooth, right? So if we use a geom smooth, it will fit a line to this data. Okay, so this is by default. And many a times we want to fit a linear line or linear model. So in that case, we can define what kind of line we want to put. So here we will give the method. So for linear, we will say LM. So that will be our linear line. Okay. So what do you notice? There is a linear fitting based on this geom smooth, and then there is also a shade. So this shade will tell you the confidence interval. And by default, I think it's 95%. So if you want to change, you can do that. And again, if you have any questions about any function, you can always go like what a question mark, geom smooth, then it will give you a whole list of arguments that you can put, right? See, we notice that without method also it will run, but if we give the method, similarly, we can specify what is like the method, formula, orientation, and I'm not able to see the confidence interval for now. But again, for every function, there are, bare minimum arguments that you can give, but there are also multiple arguments that you can add to it. Okay. So we have created a point and we have fitted a model to it. Now we will make a plot, geom bar. So again, we will give it the data, axis, yes, and to make a bar chart, what we will do, we will use a geom bar function. So let's see what happens if we use the geom bar. Okay. Okay, I'm getting an error. It must only have X or Y aesthetic. So, okay, let us give it only Y aesthetic. So what will happen? So it is creating a plot, only X statistic, it is creating a plot. But was it what you wanted? No, right? So this geom bar is not as simple as the point and line. You have to tell it what you want to plot. Okay. So if you don't tell it what you want to plot, basically in the geom bar function, you have to tell it the length of the bar, what it should be. If you don't give anything, it will assume it will work something like histogram. It will try to find the bin size, but if you don't define all the arguments properly, it will not give good results. But if you simply want to prepare a bar chart, you have certain X, Y, you want to prepare a simple bar chart, and you want length of the bar to be equal to the value of that variable, so then you can use something called identity. So you have your X and Y. So in the statistic, you want to plot the identity. So let us see if we do that, what happens. Okay, right? So this is your bar plot, and in this you need to specify your statistic that decides the length of the bar, and here we are giving identity. So here you have year, and then you have yield, and these numbers represent the values. Okay, and here again you can define the color. And there are multiple things that we can do with this. And if in a bar chart, the color will mean the outside lining. And if you want to change the fill, then you have to use this fill. Okay. So you got the line and the point and also geom bar, right? So geom bar is not the only way to make a bar chart. There is something called stat summary as well. So we will go back to our plot. So we will call it stats. We will call this function stat summary. And in the stat summary, you can define what type of plot you want. So if I want to plot geom bar, let's see what it gives me. So it will again plot a bar. And this stat summary function is not only for bar chart, but you can make a point or line, like, instead of using geom point, geom line, you can use this function as well. So basically, there are different functions to do the same thing. Okay, any questions so far? Any doubts? How to use ggplot for creating these simple graphs? Okay. Then next we have is box plot. So far we have covered point, line, and bar charts. Next, let's move to the box plot. So we can use the same. For this one, actually, we can use the same data df, right? So we have our ggplot. We give it the data, the axis, and you see we have a box plot, right? So on x-axis, what should I have? Here, y, I'm giving my yield as y. Then on x-axis, what should I plot? Because so far we've been plotting year, but if we do that, we will have like 19, 20 points like that. But for making that box plot, we need all those points. So either we don't give it any x, we will just use all our y 19 values to make a plot. So this is what we are doing here. We are not defining an x, but we are only giving y, and you calling the geom box plot, and it will give us this kind of box plot. Okay. Okay. Now let us use another example data to learn about the box plots. Okay. In R, there is another data, default data, that is called empty cars. So I'm assigning empty cars to a variable called empty. After doing that, let us view this variable by going to the environment. And this is what the data looks like. Let us explore the data. So what are the names of the column? Empty cars. So we have, what is the length of this? So we have 11 columns. These are their names. So we have MPG, that is miles per gallon. This is cylinder, number of cylinders. Then display HP. And also we have gear. And if you want to know how many unique values are there, you can use this function called unique, and then you point to that particular column. So data frame name, $. So let us see in gear column how many unique values we have. We have 3 unique values, 4, 3, 5. Similarly for column CYL, how many values we have? 6, 4, 8. So you have this data, you have this MPG, you have your number of cycles, number of gears, and these you see there are like 3 unique values, so you can use them as factors to create your box plots. because many times when you are making box plots, we are doing comparison, right? For example, we are giving irrigation using 3 methods like flooding, sprinkler, and drip. So we can use that column as factor, and we can compare what is, for example, our yield under these, like that. So similarly, in this empty car zone, what we will do is that we will plot MPG, miles per gallon, and then we can do it by different factors. We can do it like SCYL, that is your number of cylinder, basically, number of cylinders. So let us do that. So box plot, and then x-axis, we can give a factor here. Okay. Empty cars, AES. Y is our, again, we are trying to plot MPG. And on X, what should we plot? We can plot the cycle. Let's see what happens. And we want to plot geom box plot. Okay, so, okay, it did plot cycle, but I'm only getting one value. I'm not getting, a segregation by cycle. So what I can do is that I can convert this as factor by using this as factor. And if I do that, now this is the type of box plot we will get. Okay, sounds good? On y-axis, the value we want to plot, and on x-axis, the factor by which we want to, categorize our data. Same way we can, I think, plot by, we had another column that is gear. So let us see gear. So then we can make a box plot for separate gears. Sounds good? Now I will again go back to my number of cylinders, and let us change the names of the x-axis. So x-axis, let us put number of cylinders. Y can be your miles per gallon. I'll just use MPG. So this way we get, a better looking graph with more informative axis. And now many a times what we have is that we want to work with multiple panels, right? So we have divided our data by cylinder, but what if we want to see the effect of cylinder as well as gear at the same time? So we can create multiple panels. These are called as facets. So we can again make a box plot. We can make a facet by gear type 1, type 2, type 3. This can be your maybe by soil type. You can see, for example, in our irrigation example, we have irrigation, but we want to see the effect by soil type. So we can have soil type as panels, and factor can be our irrigation, for example. And but in this one, let us see how we can divide our data into multiple panels or facets. So for this, there are 2 common commands, and we will use this command called facet wrap. So facet wrap, we will use the gear to create the panel. So let's see what happens. Okay. So this is what we get. We have factors, cycle, and we are making facets by the gear. Okay. Any questions? Any questions? Making plots and then making multi-panel plots, box plots in R. And one thing that when we create plots, we don't just want to create rough plots. Many a times we directly want to use them for our publication. So for that, there are different options to improve the publication quality of the graph. For example, for let us see, there is a theme black and white function. If we do that, it kind of gives a black and white theme, black and white theme, and it improves the quality of the graph to some extent. Then if you want to change things individually, for example, I want to change, let's say, color of axis title. If I want to change the color, there is an option. It is element text. I can say color equals blue and size equal 10. So let's see what happens. Okay, so the point I'm making is that you can make changes. There's a lot of flexibility if you want to change the font size, color, name, and a lot of this is available using this function called theme. So is this clear? Okay. So I think so far, let me recap. We have covered our installing packages, loading packages. And I think when you go home, you can install those packages, because when you come back to the next class for working with Professor Ole's exercise, you can just load those packages because installing takes time. Loading the packages, then we looked at different variables that we can work with. We looked at lists, and we looked at data frames that are very useful. We can just import CSV and Excel file and work through them using data frames. Then we looked at different plots, point, line, box plot, bar charts, right? And I think we're almost out of time, but the last thing that I want to cover is how to export your data. Because you can see the data here. Many a times I see people copy this and then put them in their file. But for your publications, for making the better quality graphs, it's better to export them in high quality. So what format would you typically use? JPEG, TIFF, right? You can even export in PDF. Yes, so exporting in PDF, one trick. So if you want to, we saw a loop, for loop, right, for creating multiple plots. So if you want to export all of them, it's good, you can just export as PDF. So every page will have that image, right? But if you're using TIFF or JPEG function, it will just have one plot at a time. Did it make sense? Okay. So last thing that we want to do, that we have made all these plots, is to export them. So we will use one function called TIFF. TIFF. So let us keep, first of all, our ggplot simple. ggplot data, then axis is our factor of cycle, and our y is our mpg, and then this is a box plot. Okay, so let's see what it looks like. So it is a simple one. To export it, we can just use a simple function called TIFF. Here we will give it the file name and the extension. Then the units will tell you, like when you export a graph, you want to define how wide or how tall it should be, right? So to give it width, this in means inches. You are giving this dimension in inches. You can tell the width, let's say width 6, and height also, let's say 6. And the last thing that you want to give it is resolution. So you can go 1000 dpi, but your file size will be too large. So I think 300 dpi is pretty much useful. So let's see. We use this function, and underneath it we will use our plot. Did I miss anything? If I use it, what will happen? Did it export? Let me go to my working directory to see if it exported the file name. So this is my working directory. Did it export? It has not exported. So I think I forgot one important part. So when you write this TIFF or JPEG, so you have defined, okay, this is my starting point, whatever plot is coming after that, export it, but I need to give an end point, that is your device off, DEV off. So now everything that is between this TIFF or JPEG and this device off will be printed. So let me run it again. Let's see if it printed it. Okay. So I'm in the wrong folder, by the way. So it has printed it. This is my file, and let's see what it looks like. Okay. So that's your last thing, to export a graph. Any questions? Similarly, you can use JPEG to export the file in JPEG format. Okay. So are there any questions?
What was again the title, that line, device off?
This was when we want to export, we will use this command TIFF, file name, width, height, resolution. Then we will have the ggplot. Then we want to define what is the scope of that TIFF function. Where does it end? So it will end at device off. That is when it will cut it. Otherwise, it will be confused, like where is my plot ending? It doesn't know how many lines to read. So dev off is the where it will cut off. Okay. And one more tip I want to give you is that many a times what happens, and it has happened with me, that I make this exported, and I open my figure, it's blank. Sometimes it's blank. Maybe there is some issue. So what I do is that you can add this something called print. And if you do that, then sometimes your problem that you are exporting something and it is coming out to be blank, it can be solved by using this print, because print will make sure that something is being printed. And this print is the scope, again, of the what is being printed. So let us see, we should have a JPEG also called file name. Okay. So all of this that I have explained is also here. So you can take your time and go through all this step by step. Step by step, it will help you to create different types of graphs and also export it. So are there any questions before we close? Because it's almost time. Any questions? Yes. Yes, okay. I didn't change anything. I just changed this. I wrote JPEG, and you make sure that you give the correct extension. And again, a tip, if you are making plots in a for loop, always remember to give a file name that's flexible, right? Because if I say file name, I export it, then my loop will again export it, it will overwrite. So what I do is, I do this paste 0. For example, we had that var name I, so the var name will be different, right? So this paste 0 function, right, the paste 0 function, let's see what it will give me. Var names. So now my file name will be different. So if you are using a loop, then you can use this paste 0. It's basically concatenates. Paste will concatenate, let's say, if you use paste, it will concatenate but create a space between. If you use paste 0, it will concatenate but not creating a space between. So if you want to export files in a loop, use this paste 0 function. Okay, so is this clear? Any doubts? Okay, I think with this we can close. We can close, and I thank you again. I know that it's been a long